this is the right. Okay, closing remarks. Okay, just to recap, you guys have seen a lot of interesting ideas presented here today, whether advancing TAGE and perceptron, new auxiliary predictors that, that are meant to target, okay, where does TAGE and perceptron fall behind, and integration of new information into the prediction algorithms. I think this, no doubt, this required a monumental effort from the participants. I was amazed and impressed by the amount of progress that they were able to make in such a short period of time. You probably were able to tell the amount of compute that have gone in by the sweeps that has been done. I think there should be an award for that, or I guess you should be penalized maybe, all the energy you spent. But honestly, the amount of, within only like this 2-3 month period, an astronomical amount of work has been done. So I would like to really, applaud the participants for their amazing work that has been done for 3 months. So thank you very much. But after that, now the question of grading, ranking. So I guess drum rolls. So well, what we will be handing out we will be giving out certificates for the top 3 predictors. We printed one certificate per participant. So all authors will get a certificate each. And there's a plaque for the winner. So we'll start with 3rd place. Yes, I'll stand here because it's closer. So, all right, so 3rd place would be LVCD, predictor, most value correlated predictor, Youngman, Lingro. I'm not going to read all the authors' names. Please come in, get your certificates. Thank you. It's only you. You're going to be carrying 5 certificates today. So, congratulations, and hopefully you'll be able to get the money award as well. So, thank you, man. All right, congratulations. Thank you. So there's, I guess, we printed one for each of the authors. So you'll take 2.5 each. Yes. You can split the 3rd one. Yeah. Thank you. Thanks, guys. All right, number 2. I guess I'm going to hold only one. So, Andre came in 2nd. Congratulations. Impressive, yeah. There it is. Congratulations.
I'm not used to be 2nd.
That's a good segue into what I'm going to talk about after. So, congratulations. And last but not least, the winner of the competition. Yes, it was obvious already. Yeah, all authors are here. Please come. All authors. Please come. We will post your pictures on the website. So, congratulations. So there is. All of you. Congratulations. I could have flown to. It's easier. Congratulations. So we have the plaque, and we have a certificate for each one of you guys. Hopefully I did not. And you get 2. Oh, congratulations. You need to go all the way to the back. You got okay. Thanks, guys. Thank you. Great work. Thank you. Yeah. Thank you. All right. So, and the certificates are signed. It's not a blank signature. There's Eric's signature if you want to cash out some checks. Give it a shot. Let's see. This is recorded. I'm going to get in trouble. All right. So I'm going to show you some of the results. It's not going to take long, just so you can see how things ranked. So these are the predictors as they were presented today. This is the order in which they were presented. For comparison, we will be using the 192 kilobyte TAGE as the baseline, because that's the fair ISO budget. Even though, before I share them, I'm going to reiterate what I said earlier. We organized this championship looking for new ideas. We wanted to reignite the research in this area. Ranking is unavoidable, but we really were going after the new auxiliary predictor, the new integration, the new how to build a better Tage, how to build a better perceptron. All of these new interesting observations that you guys have brought in. So kudos to you for all the hard work. So for ranking, so this chart here shows the different predictors on the x-axis, the 9 predictors. They are sorted based on MPKI reduction. This is MPKI reduction. The 2 bars are the training set and the full set. Ranking was done based on the full set. I just want to point out 3 of the submitted predictors delivered lower MPKI, not as good as scaled Tage, but that doesn't take away from the contributions. It's all about the new ideas. I guess some of these guys, like the pre-computation, the auxiliary predictors, these can be easily integrated into any other branch predictor design. So this doesn't take away from the huge amount of work that have gone in and the interesting observations that were made. But that at the very further end over there, the top 3 predictors. So great work. We appreciate your contributions. The interesting thing to note here is ranking based on the training set versus the full set. It was largely the same, especially at this end of the diagram. So this is a MPKI reduction, reduction in cycles in the wrong path. It was also largely the same. There's only this, like you can see, this a little inflection here, cycles in the wrong path reduction. But in general, it was similar trend between MPKI and cycles in the wrong path. I was hoping that we'll get different trends and different observations when we had this, criticality perspective or cycles in the wrong path perspective, energy perspective, however you want to describe it. But it came back largely the same. I just want to just zoom in a little bit and look at the top 3 predictors and how they performed across the different benchmark categories. Interestingly, the run LTS, the winner predictor, was actually winning across all categories. In general, it was largely the same ranking across categories, except for like in the infra category, where like 3rd predictor was ahead of the 2nd predictor. But in general, it was smooth expected distribution. MPKI was tracking very well with cycles in the wrong path, so probably we'll drop that if we choose to continue this, drop cycles in the wrong path as a metric. Or if you have a more detailed CPU simulator, that could change the story. But in our data here, it didn't. So cycles in the wrong path also still the same trend across the different workload categories. One thing I mentioned earlier that in infra workloads, we have a large number of instruction cache misses. So I wanted to run just an additional design point and see what if we have a perfect L1I and L1D in the simulator. So this is just showing for the first predictor how does a reduction in cycles in the wrong path changes when you have perfect caches. Again, each one of these has its own respective baseline. It's not the same baseline, but you can see that in the original data, the reduction in cycles in the wrong path with regular L1I and L1 data caches was very small. When you are hitting in the cache, it becomes a significantly larger number. And that is, I guess modern processors are really good at hiding cache misses, decoupled fetchers, bigger structures, and so on. This, I just want to flag this one in particular. But overall, pretty much all of the predictors performed better on this metric when we have perfect caches. So this is, I think, all the data I wanted to show today. We'll see a more detailed evaluation in a more time accurate simulator. Any other last comments? Okay. So I think, just to sum up, you guys have seen the great work that has been done. It was a monumental effort. Please keep working on branch prediction. We really need all the good and creative ideas. And implementability is something we would love for everyone to think about, but it shouldn't be a limiter to introducing new ideas into this area. There's like 40 years of research on branch prediction or something like that. It's very rich. It's very hard to beat state of the art. So we need new ideas, new observations, and let's just put budget aside, complexity aside for now. Let's find correlation, because that's the real problem here. And thanks to all the participants, program committee, the organizers, Saransh. I appreciate all your hard work. it's been a monumental effort for us and you guys, I'm pretty sure. And thank everyone who joined us here today. Thank you. It's a full house. I appreciate that. And we will, as asked, we will release the papers, the source code, recording if Mahesh will give us access to the recording after. Zoom did not work, the recording, so...
Slides?
And the slides. Everything will be on the website. I just didn't want to post it before so that I want to make sure people will show up. So now that we have the event held, thanks everybody, and that's all. Thank you. Feel free to